Welcome to the deep dive. Okay, here's the thought. What if the biggest environmental liabilities a nation faces, the ones costing billions, seemingly endless problems, what if they could actually be transformed into, well, their greatest assets?
It sounds almost too good to be true, doesn't it?
Exactly. Not just solved, but like turned into something profitable, regenerative, even world-changing. A total paradox.
It really does sound like one. And today, yeah, we're going to unpack exactly how that might just be becoming a reality. Our deep dive today is into CarbonLab. They're a New Zealand-based company, and they're pioneering this really multifaceted approach, addressing huge environmental and economic challenges. Everything from invasive species, agricultural sustainability, all the way to national energy security.
That's right. And for this deep dive, we've pulled together quite a stack of sources. We've got comprehensive white papers on biotar, which we'll get into, detailed case studies looking at large-scale wilding forest management, that's a big one, investor summaries, even strategic memos on green methanol.
A really solid base to work from.
Absolutely. So our mission today for you listening is to give you a really comprehensive understanding of how CarbonLab's, innovative tech and their business models aim to turn these massive problems into perpetual value. Get ready to see how deep tech, forestry, green chemistry, how they're all converging in some really surprising ways. It's about seeing problems not as dead ends, but as opportunities for huge shifts.
Okay, so let's set the scene first. Let's look at the landscape of these problems. Starting with a crisis in New Zealand that maybe isn't on everyone's global radar. The wilding pine infestation.
Okay, let's unpack that, because this isn't just, a few stray trees we're talking about.
No.
The scale is immense.
Yeah.
Over 2 million hectares of land covered by these wilding kinds across New Zealand.
2 million?
Yeah. To give you a sense of scale, that's roughly the size of a country like, say, Slovenia.
Wow.
And it's getting bigger. It's swallowing up land at an alarming rate. They estimate 90,000 hectares more every single year.
90,000 hectares a year.
Yeah.
That's exponential growth, really.
Right. It is. And a huge chunk of this is actually on public conservation land, PCL, that's managed by the Department of Conservation, or DOC.
Right. And what really stands out here, I think, is how these trees are classified. They're officially a weed, not a resource, a weed. So DOC is staring down this estimated NZD $6 billion eradication cost just to get rid of them using current methods.
6 billion. And what are those current methods? Like spraying?
Yeah, mostly spraying, pulling saplings, cutting down trees, labor-intensive stuff. And here's the absolute kicker. There's zero revenue return from any of that effort. None.
So it's just a massive cost sink.
Pure cost center. Just a relentless drain on resources.
Which makes sense then why it's so hard to keep up. You mentioned the current methods. They're not really effective enough, are they?
Not against that scale of spread, no. Funding for these programs, well, it's dwindling. Control efforts often get restricted. Reinfestation is super common. So that exponential spread just continues unchecked.
Right. And you mentioned the Branch Lethem Conservancy. That's a specific example.
Yeah, it's a really striking one. It's this massive 56,000 hectare area. Just that one site has an estimated $90 million eradication cost.
90 million for one area.
It's become this major seed source, constantly reinfesting huge parts of the South Island. It really highlights the crisis.
Wow. Okay, so that's the wilding pine problem. Huge scale, huge cost. But you mentioned it connects to other issues.
Yeah, it's easy to get lost in just the pines, but it doesn't exist in a vacuum, right?
Yeah.
It connects to other critical issues, especially for New Zealand's vital agricultural sector. Think about dairy farmers. In Canterbury's Amiri Basin, for instance, they're grappling with two really pressing issues.
Okay, what are those?
First, managing nitrate levels leaching into waterways. That's mainly from cow urine patches and nitrogen-heavy fertilizers.
Yeah.
A big environmental headache.
Right, nutrient runoff.
Exactly. And second, irregular water uptake. Irrigation efficiency problems because river levels like the Waio and Hurunui fluctuate so much.
And the local soil conditions there, they don't help, do they?
They make it worse, actually. You're talking predominantly stony silt loams, alluvial fans, basically soils with very low water holding capacity.
So water just runs straight through.
Pretty much.
Yeah.
Which means nitrates percolate really rapidly through the soil, straight into aquifers and streams. It's a direct line for pollution.
Okay, so land issues, water issues. What about energy? You mentioned that too.
Yeah, shifting gears a bit, New Zealand also has this looming energy security risk. There's a natural gas shortfall that's actually threatening industrial operations and exports.
Really? Like what kind of operations?
Well, a prime example is Methanex. They're a huge methanol exporter, like $800 million
Mm.
a year business, employs hundreds of people, underpins regional economies, but they're at risk because the natural gas reserves they rely on are declining rapidly.
So they can't get enough gas to run at full tilt?
Exactly. Operating below capacity, even facing high court disputes over gas access. It's serious.
And is there a plan B, like a green alternative for methanol?
Well, that's the crucial point. There's no clear national plan, no viable green substitute feedstock ready to go for methanol production at that scale.
Yeah.
It's a major vulnerability.
Okay. And this isn't just a New Zealand story, is it? You mentioned forestry globally.
No, definitely not. The woes of traditional forestry,
Uh-huh.
that's a global problem. Forest owners everywhere are seeing their margins just erode. We're talking typically earning only maybe $2 to $5 per ton of harvested logs after costs.
$2 to $5 a turn. That seems incredibly low.
It is, and why? Well, it's a mix of things. Increased regulation, rising harvesting costs, commodity prices for logs staying pretty static, and growing environmental concerns, even penalties.
Plus the environmental impacts of logging itself, right? The stuff left behind.
Oh, absolutely. That's often overlooked but significant. Traditional forestry leaves behind these massive volumes of slash.
Slash, that's like the branches, the offcuts.
Exactly. All the woody debris left on the forest floor. As it rots, it releases COO, degrades the soil, leads to nitrate runoff. And we've seen how it can cause real physical destruction during floods, getting washed downstream. It's a huge environmental and economic liability. Basically, a wasted resource.
Okay, so we've got invasive species costing billions, agricultural pollution, energy insecurity, and unprofitable, damaging forestry practices. That's quite a list of challenges.
It really is. Multifaceted, deeply interconnected problems.
So how on earth does CarbonLab propose to weave all these threads together into a solution that actually works? This is where it gets interesting, right? Their approach to harvesting.
This is where the paradigm shift really kicks in. They call it forest harvesting as a service, and is done entirely from the air.
From the air. Oh.
Using their proprietary tech, Skyborn.ai, it deploys autonomous drones and robotics for aerial forest harvesting.
Okay, drones for logging, that sounds futuristic.
It kind of is, but the why is compelling. It completely eliminates the need for building roads into forests or doing large-scale clear felling.
So much less destructive.
Massively less. It drastically reduces that slash problem down to minimal levels, makes harvesting way more efficient, more cost-effective, and crucially, ensures very low risk for employees and the local community. It's bringing precision and, well, a light touch to a traditionally heavy impact industry.
Okay, so what does that mean for the forest owner? You mentioned low margins before.
The potential impact is, frankly, staggering. Their sources suggest, get this, a 25x potential increase in harvest margin for the forest owner.
25 times.
Plus 70% less investment needed for forest roading, 90% fewer staff required on site, and incredible 99% less environmental damage.
Wow.
And they even project 50% higher forest valuations as a result.
That's transformative. So how does CarbonLab make money?
They charge 30% of the harvested value for providing this service. And it's not just theory. They've had success with their version 1 experimental drone and robotic wood chipper. Stage 1 autonomy is designed. They've done their Civil Aviation Authority applications. It's moving forward.
Okay, so they harvest the biomass differently. What happens next? It doesn't just get piled up, right?
No, exactly. This is the next key step. The harvested biomass, like those wilding pines, it's processed right there, on site, using what they call mobile microwave gasification reactors.
Mobile microwave. Okay, break that down.
Think of it like a highly efficient, contained system. It uses microwave energy to break down the wood chips in a low-oxygen environment. This stops it from just burning up. Instead, it converts the biomass into valuable gases and solids, kind of like making charcoal, but way more controlled and producing more outputs.
And it powers itself.
Yeah, it's another clever part. It includes a self-generating power system. The syngas produced during gasification.
Shingus.
It's a synthesis gas, basically. A mix rich in hydrogen and carbon monoxide. It's a clean burning fuel. So that syngas fuels generators right on site, creating an off-grid carbon-neutral harvesting system. It powers the whole operation.
Okay, self-powering, processes on site. What are the actual valuable outputs from this microwave process?
Right, this is where the value really stacks up. First, you get activated biocarbon, which is also known as biochar. That's a high-value consumable, part of an $8 billion global market already.
Biochar. We'll definitely need to dig into that more later.
Hmm.
What else?
Then there's green methanol. We talked about the Methanex issue.
Mm.
Well, this process produces methanol, but it's green methanol. It's significant because it's a carbon-neutral fuel. The market for it is projected to grow massively over USD $37 billion by 2034. Critical for shipping, aviation, clean fuel transitions.
And they mentioned something about it being auditable.
Yes, world-first auditable status from source to use, meaning you can track its entire carbon-neutral journey. That's huge for verification.
Okay, biochar, green methanol,
Uh,
anything else?
Yep. They also generate biocarbon-based carbon offset removal certificates, or CORCs.
Ah, carbon credits.
Yeah. Exactly. But specifically removal credits. Because the process takes carbon from the atmosphere via the trees and locks it into stable forms like biochar. These credits can be sold to companies needing to offset their emissions. And that's potentially a $50 billion plus market by 2030.
Wow.
And one more. Food-grade green corals, also captured during the process. This is vital for things like food processing and cold chain exports. Another $8 billion global market.
Okay, wait. Let's put this in perspective. You said earlier a forest owner might get $2,005 a ton for logs.
Right. Maybe $4,800 for a whole truckload, about 43 tons at the wharf gate. That's the traditional model.
But with this CarbonLab tech, processing that same 43 tons of biomass on site.
Generates potentially up to $60,000 in value from those combined outputs, the biochar, methanol, CORCs, COROs.
60,000 versus 4,800, that's more than a tenfold increase in value from the same raw material?
It's a completely different equation. It flips the script from low-value bulk commodity to high-value specialty products. They even give a daily revenue example for just a 1 milliUW CarbonLab system that's sort of their standard unit size. Processing 43 tons of wet wood chip a day could generate an estimated 58,014.2 NZD daily.
That's serious revenue. It really reframes that $6 billion cleanup cost for Wilding Pines, doesn't it? It's not just a cost anymore, it's feedstock for a profitable industry.
Exactly. It turns a massive national liability into potentially a multi-billion-dollar self-sustaining carbon-negative industry.
Okay, let's dive deeper into some of these outputs. You mentioned biochar helping those dairy farmers in the Murray Basin. Let's connect those dots.
Right. So biochar, what is it exactly? It's this highly porous, charcoal-like substance. You make it by pyrolyzing organic waste, basically heating it up intensely with very little oxygen, in this case, using the Wilding pine biomass as the feedstock.
And the key thing here is the location, right? You said it creates a closed loop.
Precisely. The biochar for the Murray Basin farmers would be sourced directly from CarbonLab's Wilding pine eradication projects happening nearby in the Hanner Basin. You're solving the pine problem and creating a product to help solve the farming problem right next door.
Okay, so how does this charcoal stuff actually help with nitrate leaching? That's the big issue for those farmers.
It works in a few clever ways. Because it's so porous, it has a huge surface area. So first, it absorbs nitrate and ammonium ions. Basically, it traps them, holds onto them like a sponge.
Looks them up before they wash away.
Exactly. Second, it actually modulates the soil microbes. It seems to support the beneficial denitrifying bacteria, the ones that turn nitrates back into harmless nitrogen gas, and it slows down nitrification, which is the process creating the nitrates in the first place.
Interesting. So it affects the chemistry and the biology of the soil?
And third, it improves soil water dynamics. It holds onto water better itself, which slows down that rapid percolation, giving nutrients more time to be taken up by plants instead of leaching out.
Okay, that makes sense. Is there proof this works? Like field tests?
Oh yeah, absolutely. There's good evidence. A Lincoln University study back in 2014 found biochar cut nitrate losses by up to 29% under typical Canterbury grazing conditions.
Almost a third reduction.
Yep. More recently, a 2021 NZATIC research study combined biochar with nitrification inhibitors, those are other compounds farmers sometimes use, and they saw up to a 40% reduction in leaching.
40% is huge.
It is. And looking globally, a big meta-analysis looking at 75 studies worldwide found a median nitrate reduction of 31%. So the evidence is pretty consistent.
And it's not just about stopping the bad stuff leaching out, right? It actually helps the soil itself, especially those stony ones.
Definitely. For those poor soils in the Murray Basin, biochar can retain 15–30% more water than the surrounding soil.
Okay, so like adding a sponge to gravel.
That's a good analogy, yeah.
Yeah.
It makes the soil more resilient to drought because it holds onto moisture and releases it more slowly to the plant roots when needed.
Does that translate to better pasture growth, more feed for the cows?
Studies suggest it does. An Italian study saw a 12–16% pasture yield improvement in similar sandy soils. Other research observed better nutrient uptake by plants and increased root biomass. And there were some unpublished NZ dairy trials suggesting maybe a 5–10% increase in dry matter yield, especially when the pastures were under water stress.
So potentially more grass, using water more efficiently, and less pollution. Seems like a win-win. How much do they need to apply?
The recommended rates are usually around 10–20 tons per hectare. It's not a tiny amount, but the benefits seem long-lasting. And it works well with other tools farmers are already using to manage nitrogen.
Right, it's not a silver bullet, but part of the toolkit.
Exactly. And importantly, it could really help those farmers meet the strict nitrogen loss limits set by Canterbury's Land and Water Regional Plan, potentially helping them avoid fines or restrictions from Environment Canterbury or ECAN. That's a big deal for their license to operate.
Okay, so biochar seems like a really practical, beneficial output. Now let's shift back to that other major product, green methanol. One of the sources called it the underestimated protagonist of the energy revolution. Even liquid sunshine.
Yeah, that framing really caught my eye too. Because beyond just solving New Zealand's immediate Methanex gas shortage problem, methanol has this potentially huge global significance as a disruptive energy carrier.
Disruptive how? What makes it special?
Well, first, its properties. It's just a transparent liquid, easy to handle like gasoline, but it has a very high energy density, especially when you think about storing hydrogen. 1 liter of methanol can store almost 100 grams of hydrogen chemically bound within it. That's apparently 3 times the capacity of comparable compressed hydrogen storage and an incredible 15 times the energy density of a standard Tesla battery by weight.
15 times. Okay, that's impressive. But isn't methanol usually made from fossil fuels, like coal?
Traditionally, yes. Coal to methanol or natural gas to methanol. But the breakthrough, what some are calling the green gene mutation, is the shift towards making it from captured carbon dioxide plus green hydrogen.
Green hydrogen meaning hydrogen made using renewable electricity.
Exactly. So you're essentially taking CO2 out of the air or from industrial sources or from biomass gasification like CarbonLab does, reacting it with clean hydrogen and creating a liquid fuel. You're recycling carbon. Chinese scientists have apparently made big strides here, achieving a process that consumes 1.4 tons of co-euro for every ton of methanol produced.
So it actually uses CO2 as an input. And the sources mentioned 4 disruptive advantages. Let's break those down. First one, environmental protection.
Yeah, this is huge. Compared to burning gasoline or diesel, using methanol as fuel results in massive reductions in air pollutants. We're talking PM 2.5, those nasty fine particulates reduced by 99%.
99%.
Nitrogen oxides reduced by 80%. And over its full life cycle from production to use green methanol can offer up to a 70% reduction in carbon footprint compared to fossil fuels. It's just fundamentally cleaner burning.
Okay, cleaner air, lower carbon. That's a strong start. Second advantage was resource strategy.
Right. This means methanol isn't tied to specific geographic locations like oil or gas reserves. It can be produced from all sorts of feedstocks. We mentioned CO2 and green hydrogen, but also biomass like agricultural straw. One source mentioned 1 ton of straw can yield about 0.3 tons of methanol.
So countries could potentially produce their own fuel domestically from waste products, enhancing energy security.
Precisely. Less reliance on imports, more energy independence.
Makes sense. Third advantage, cost crushing. That sounds dramatic. Is it really that much cheaper?
The numbers are pretty compelling. Methanol cars, for example, apparently cost about 1/3 as much to run per kilometer compared to gasoline cars in China, like 0.25 yuan per kilometer.
1/3 of the running cost.
Yeah. And the infrastructure needed to handle it is much cheaper to set up than for, say, electric vehicles or LNG. Renovating a gas station for methanol is apparently only 1/110th the cost of installing EV charging piles and just 1% of the cost of building an LNG station.
Wow, so the barrier to entry for infrastructure is much lower.
Much lower, which makes wide-scale adoption potentially much faster and cheaper.
Okay, environmental benefits, resource flexibility, lower costs. What's the fourth one? Application scenario fission. What does that mean?
It basically means methanol is finding uses in a rapidly growing number of areas. It's not just a theoretical fuel. Shipping is a big one right now. Major companies like Maersk have already ordered a dozen large container ships designed to run on green methanol. That's happening now.
Okay, maritime fuel. Where else?
It's being looked at for distributed energy, like using methanol fuel cells to power remote 5G base stations, providing reliable off-grid power. And even aviation is exploring it. Comac in China is developing methanol hybrid drones, so its potential uses are really expanding or fissioning outwards.
So it's not just a replacement for gasoline, it's enabling new things too.
Exactly, which leads to that quote from Nobel Prize winner George Andrew Olah. Methanol economy is the shortest path to carbon neutrality. It's a powerful statement about its potential.
It really seems like methanol could be a key piece of the decarbonization puzzle, linking renewable energy, carbon capture, and liquid fuel needs.
I think that's the potential, yes. It connects a lot of dots.
Okay, let's bring this back to the bigger picture for New Zealand and CarbonLab. This wilding pine problem, as awful as it is, it's actually become a unique opportunity for them.
In a way, yes. It serves as CarbonLab's national laboratory, as one source put it. It's the perfect, large-scale proving ground for their entire integrated system, the aerial harvesting tech, the mobile gasification, the biochar production, the methanol synthesis. They can test, refine, and demonstrate it all, tackling a real conservation crisis in partnership with the Department of Conservation, DOC.
And DOC seems to be on board with this.
Very much so, based on the quotes we have. Brad Chandler, who's a senior technical scientific advisor and wilding conifer expert for DOC, had some strong words. What did he say? He called CarbonLab's method world-leading. He said it presents DOC with a very rare chance to support and be involved in a world-first, potentially groundbreaking opportunity.
That's high praise from inside the government agency dealing with the problem.
It is. And he went even further, stating flatly, CarbonLab can solve the national wilding conifer challenge.
Wow. That's a huge statement of confidence. Can solve it.
It really is. It underlines the potential they see in this integrated approach, moving beyond just costly eradication to value creation.
And the scale of that potential solution is significant, right, in terms of carbon removal.
Absolutely. At full scale, CarbonLab is on track to become New Zealand's largest permanent carbon removal operation. That's key locking carbon away long-term in biochar. Just one large 80 milliW site, like the kind needed for that Branch Lethem Conservancy we talked about, would avert over 1.5 million tons of co-euro equivalent per year.
1.5 million tons a year. How does that compare?
That's equivalent to the annual emissions from about 310,000 people, or roughly 4.4% of New Zealand's entire national emissions footprint, just from one site tackling wilding pines.
That's a meaningful chunk. And you mentioned they have a dual approach, not just conservation land.
Right. That's crucial for their business model. Track 1 is this public-private collaboration with DOC for conservation land, dealing with the wilding pines. Track 2 is commercial deployment in plantation forestry globally, taking the same tech, aerial harvesting, mobile processing to traditional forest owners worldwide who face those low margins and environmental pressures we discussed.
So they plan to take this global.
That's the ambition. The plan is to showcase this working solution proven in New Zealand to the top 5 global forest owners. And their goal is pretty bold. They aim to fulfill 25% of global forest owners' harvesting requirements within 10 years.
25% of the global market in a decade. Okay.
It's ambitious, but it positions New Zealand potentially as a major exporter of climate-positive technologies. It could create a whole new climate asset class, unlock significant green finance. It's a big vision.
And just for context, not as a pitch, but for listener understanding, how are they funding this next stage?
Right now, they're in the process of raising NZD $700,000. That's to finalize their 1 milliW pilot system. That daily revenue example was based on that size, and get everything ready for the big 80 milliW scale-up. And their long-term path for investor return. They're looking at options like a trade sale to a larger company, maybe an IPO down the line, or even just a long-term dividend model, framing the whole thing as an intergenerational asset.
Intergenerational asset. That framing really emphasizes the long-term sustainable value creation they're aiming for, doesn't it? Not just a quick fix.
Exactly. It's about building something lasting that continuously turns waste and liabilities into value and solutions.
Okay, so as we wrap up this deep dive, let's maybe circle back to that core idea we started with. How CarbonLab is taking these huge environmental liabilities, invasive pines, agricultural waste causing pollution, and turning them into, well, perpetually revenue-generating assets and climate solutions.
Right. It's not just about tackling one problem in isolation. It's the synergy between them.
That really feels like the aha moment here, doesn't it? Seeing the interconnectedness, these things that seem like separate problems, conservation nightmares, farming challenges, energy insecurity, they're actually linked. And a single integrated platform, using clever technology, can potentially offer solutions that ripple positively across all those sectors.
It definitely shifts the perspective.
Yep.
Instead of silo challenges, you see opportunities for, synergistic solutions, from costly problems to valuable assets.
Okay, so maybe a final provocative thought then for you, our listener, to take away from this.
Building on that idea, What other hidden liabilities or maybe overlooked waste streams exist out there in our world? Could be environmental, sure, but maybe industrial. Even societal problems, things we currently just see as costly burdens.
Things that maybe, with some truly innovative thinking like we've seen here, and maybe the right kind of technological platforms, could they also be transformed, turned from problems into valuable, maybe even regenerative assets for the future? How can you start rethinking challenges not as dead ends, but as opportunities for exponential transformation?